Before I start, I would like to say that we took our authority to be a bit more creative with some of the slides. We'll just get back to the technical point after a few. But yeah, communication. So we all understand some charts, some graphs and everything, but how can we make everyone understand in a simple term? That was our task. So we took the liberty of creating some memes and yeah, LCA communication. So we are sharing the life cycle assessment results, our interpretation, why it is necessary and everything with people, general public, so that we can create an awareness for it. Next slide, please. Next. Three more, please. Yeah. Yeah, so yeah, we had some challenges like we had to make it simple, we had to make it understandable. At the same time, we had to include all the key aspects. And the life cycle assessment is basically a start to finish process. How can we include this? First, we took a few key aspects into our consideration. And the first one we took was water. Next slide, please. So, a person a day consumes 120 to 130 liters water per day, and this does not only include the direct consumption, but also all the indirect consumption, including the water taken while washing clothes, electricity usage, and everything. And per household, we can say that a person consumed around 300 liters per day. When we compare a person to a fabrication per day consumes 30 million liters or more. And that's a big number. A person to a fab per day consumption is so different that it's insignificant how much a person consumes. Next slide, please. So we like to introduce 4 key topics or key notes to this discussion. First is lifeblood technology. Water is the lifeblood of our technology. We need clean water for every fabrication process, for everything. But at the same time, we are giving out wastewater. We are giving out not so useful water. But water is already a limited technology, a limited thing. We don't have enough water to continue, and we won't be having enough to even finish our daily purposes if we continue to consume a lot of water in process of making chips. But at the same time, water is also a good thing for the microfabrication because it ensures that we have clean wafers. It ensures that we have usable wafers. And less water consumed by a fabrication company can be a advertisement aspect, saying that we are a company which is eco-friendly. We are an industry which constructs or builds our materials with our earth in consideration. Next slide, please. So not just companies. Every time we use a product, every time we use electricity, every time we send a mail, we are also consuming a lot of natural resources. And this include water, carbon dioxide, and all the other resources, which is also consumed by these industries. Next slide, please. So, going green not only allows the companies to advertise themselves, but also allows the sustainability of these resources and for a better future. And next slide, please. We also considered energy consumption by the IPMS, and annually it consumes around 34 gigawatt per annum, and we compared it to the size of Hambacher first, and if we were to build a solar, if we were to compare it to the energy that the solar panels would take to produce that much, we would have to take 9 football fields equivalent, or 1/10 of the Hambacher forest. Next slide, please. Yep. Previous. Yeah. Also, in terms of greenhouse gas emissions, we considered some of the top companies such as Intel, Samsung, and TSMC. So Intel alone produces 34.4 million ton equivalent of carbon dioxide. So I would like you to all imagine Berlin City. In Berlin City, we have 6-building high black cloud. Yes, that's how much the 34.4 million tons can be compared to. And Samsung and TSMC together produces even more amount. So it's high time that we push towards a greener technology, a greener way to develop these technologies. Thank you.